It is, isn't it?
You remember that game, Edge or whatever, where you put the blocks on a little thing and you have to get to the other side? It's a square board and you have little tiles that are like...
How about that? Is that better? Okay, cool. It's funny because it looks fine on the screen, it just looks like crap on the big screen. So real quick, friends.
It's cool.
The point of this exercise, and thank you for the in-class quizzes. Y'all get 10s on them, of course, because I'm assuming you did all. I can't check your rolls because they were random, so I'm assuming you did it right.
So we could have just made up numbers.
You could have made up numbers.
1, 1, 1, 1, 1.
Somebody always says that every term. I love it, but you didn't. Now,
He's got you there.
that's such a bastard. I say things sometimes. Okay.
And the gloriousness. Nectar of the gods. Andre would be.
Why did I have you do this? Why did you do the samples? What was the motivation about? It's about a half an hour ago now. Why did you do this? Well, the quiz points were how I motivated you to do it. Alicia?
To see whether or not the average that we actually rolled was what we calculated based on.
Thank you. Perfect. To see if the average you got, on average,
Over time.
over 25 trials, over time, was similar in any way to the average of the distribution. Now, why didn't we just stop by you guys taking the dice and rolling around in your hands and looking at that? Because that was... well, it's not possible. It's fiction, right? You can't actually go get your population. The best you can do is by looking at samples drawn from your population, analyzing the samples, right?
Yeah, it's better to have more than one sample.
Good.
Better randomization.
Exactly. Hold that thought too. I want to come back to that on Wednesday as well, because I do have a nice Monte Carlo to look at to help us drive that point home. Hold that thought though, Riley. Thank you. So the question I have is, how did we do? Let's go front to back. Red, how did you guys do? Did your samples catch the average of the distribution? In case you've forgotten what red looked like, your red average was about 9.17.
Yeah.
Did we do pretty good?
Yeah.
Check it out, look at that. This highest spike right here indicates, looks like we got, now, granted, that bar goes from 9 to 10, but the average is in there, isn't it? Good, we tracked it, if you will. Okay, let's go back to blue. How about blue? How did blue do?
Hey, you deleted
Their spike is from 8 to 9. Oh, I'm going to put it back, don't worry. I'm going to put it back. 8 to 9. Let's look back at blue. Okay, blue's up here. 8.16. So it's in there. Cool? Cool. I'm never going to put it back, Riley, for a very important reason. Yellow, here's yellow. Your guys' average, I believe, was 4.5. I just saw it go by. Is that correct? Yellow?
Yes.
4.5. Look where your highest spike is. Contains 4.5. Green, your average was 7. Cool, interesting little double hump here. So it's hard to see exactly which one we should believe. It looks like we may have missed it on this one. Don't worry, we'll come back to that one.
Got a camel.
And this guy's orange, yes. Your average was 7, if I remember correctly. And look at that. Look at that. Taryn, go.
We only know that that lines up with the population.
Did you hear what Taryn just said? Say it again, sir. Sister. Sister. Say it again. No, say it again. Say it again. We only know that because,
It's lined up with the population.
which we inadvertently, we fictitiously counted, didn't we? Remember, we only know that the average is there because we knew what the average was ahead of time. But let me ask you a question, Taryn, and everybody else for that matter. If we hadn't have gotten the population average, can we look at this and know roughly where it is?
Yeah, but it could change on the map.
Oh, hold that thought till Wednesday. Good. Taryn's got an exceptionally good point. There's a bit of fiction involved in this. The reason we are so excited about these curves is that the curve is capturing most of the time where the population average is. But the only reason we know that is because we knew what the population average was. But take a step back. Suppose we didn't. Can you give me where the population is between two values looking at this red curve?
Yeah, because of one first couple weeks of class where you told us how to do that from a graph.
Oh, but correct. But that was finding the average of this distribution, Riley.
What if you had
Could we then go, okay, the average of this one is somewhere between 9 and 10. Nobody says you can then reverse engineer that that's the population's average too. But it appears that that's what's actually going on, doesn't it? It appears that we are getting a glimpse of the population without actually having the entire population. Taryn, your point is beautiful in that we did know the average is going in, correct? We did know the averages going in. But the kicker is we didn't have to know them because right here I know it's between 9 and 10. Right here, I know it's between 8 and 9.
What if you did the average?
Hold that thought. Hold that thought until Wednesday. I've got a Monte Carlo simulation that does up to 10,000. And that's the thing. You asked the question, Taryn, I think it was about 2 weeks ago now. No, this is the
Next turn. And you'll wait till
No, you stop that back there. You stop that back there. You asked... I'm trying to answer that question. You asked this phenomenal question. And I think, Michelle, if I remember correctly, you chimed in too. The more you sample, the less uncertain you should be. So for right now, I can say the average looks like it's between 8 and 9. Well, suppose you need it to be closer than between 8 and 9, maybe 8.5 to 8.6. It seems that we should be able to sample more and get that more precise, right?
Yes.
Which would mean this graph would do what? In theory, what should this graph do if we sample more? Do that again, do that again, do that again. Wait, Taryn, do it. And Riley, do it. Both of those things should happen. You should see the graph getting taller and narrower, right? Did anybody notice? Did anybody notice? You guys caught 2 of the 3 very important things, and you got the 2 hardest of the 3 very important things. Number 1, you've realized that the average is at the highest point of the curve, or the highest point of the bell curve. Number 2, if we sample more, they should tighten and rise. What's the 3rd obvious question? Maybe it's not that obvious.
How much caffeine have you had today?
Not that.
Enough to party. What would happen if we took the average of all the averages?
We are going to do that soon. Give me till Wednesday. Do that too. Did anybody bother asking? Whoops.
Well, somebody did, just not here.
Did anybody? What's the shape of all these distributions that you guys got up here?
Bell curve.
Why? The original populations weren't.
That's what I was curious.
The original populations, except for red. Red was, yes. But notice how red got more bellish? Red went from this to that. So it got super tight. The rest of them turned into Bell Sandy.
Is it because it's still on average over time? Because you still have 6 numbers, you still have 36 possibilities, and
you have more trials.
that
But you added more.
so eventually it
have
will
that
even out.
I love what you're saying. Let me go to the blue curve, just for the sake of argument, the blue curve. Because the red one's great, but it's like an uber bell, it's too tight, you don't see the tails enough. You actually see tails here, don't you?
Is that because it's 2?
Now, if you go, hold that thought, Randall, hold that thought. Let me finish this first, and I'll get back to I love what you're saying. If you go look at the blue, that's the population curve. There's no bell in there. There's no bell in there. I mean, you could pretend that there's kind of a bell with a missing tail. But the question is, why is it when you start sampling 4 at a time that the extremes disappear and the middle builds up? Terry, go ahead.
Have less trials, so the average is going to build more.
But I guess my question is, how come?
Because it's more likely to get the averages than it is the outliers, and when you do all of them, you have to account for the outliers, and when you just sample, you don't always get the outliers in that.
I love that statement. Can I change one word, just one word, Riley? I don't want to call them outliers, and here's why. 12, for example.
It's not an outlier, but it's on the outside.
It's the extreme value.
Yeah.
Good. It's on the outside. I don't want to call it an outlier because 3 out of 36 is 1 out of 12. That's 8% occurrence. That's not really unusual, is it?
But it's not the average.
Correct.
It's not the average.
But there's a big difference between
that's
rolling a
an
12 once and rolling a 12 4 times, isn't there? It's hard to roll that 12 4 times. It's also hard to roll that 2 4 times. And that 3 4 times, or this 4. It's easier to roll closer to the average. I think is what Tara was getting at. It becomes easier, especially with repeated trials, to roll closer to the average, because that's, if you think about it, is what an average is, right? It's the most common, it's modal, it's median, it's average on a bell curve. It shouldn't be that hard to get if it's average. Although, now, it's kind of hard to call, like I said, it's kind of hard to call these outliers, because they do happen fairly
But
frequently.
they're outside of the 2 thingies on bottom.
Exactly. So when you look at this and you realize this spike was one of the highest spikes on the population curve, but it's hard to continually throw 11s. So that one gets knocked down and what rises up are closer to average. That's exactly right. Terry, that's what you were getting at too. Absolutely. I want to respect what you guys said earlier, because Randall, you were saying, how about more trials? I've got a simulation. Let's save it for Wednesday, though, if you don't mind. I'm going to kick you out here a little bit early, give you some time to work on the stuff that you need to work on. Did everybody turn their quizzes in? Let's make sure all your names are on so I can give you credit for them. And if you don't mind returning the dice, that'd be fantastic too. You got it. Those last 2 points are just for somebody on the screen. Somebody. Okay, you're golden. Cool. Thank you, Andrea. Of course. Who's your camera? Aha!